All right, hi guys. I'm going to help you out with this review if you need some help from me as to how to do any of these problems. You also got some free answers in the practice by following along with me as well. So I'm going to do like one of each, and that way you can have something to base all of your other practices off of. So you can see on my screen that what I have open right now as well is a periodic table. You're going to need that. And I also have a calculator open as well. You're going to need a calculator. Like I ideally like to have a real one in my hands. I just think it's easier. But you can have your computer calculator open as well. Okay, so I'm going to start off by quickly doing number one here, mole to mole. Okay, so I want to make sure that you guys are reading these questions. It says if you have, ooh, can I have a pointer here? That's cool. Okay. This one? No? Okay. Sorry, I'm messing around with this when I shouldn't be. So if you have 3 moles of iron, okay, check that out. 3 moles of iron. How many moles of iron oxide do you need or can be produced, right? So I'm going to start off with exactly what they give me in the problem. And the cool thing about doing these on the computer is like control copy, control, paste. I can just straight up paste from my problem. We don't want the number 2 in there. What was given to me in the question, right? So I'm putting 3 moles of iron at the start of my problem. And you guys know our mantra, what goes up must come down, what goes up must come down. So to finish this problem, I'm going to take the moles of iron. I'm just going to copy it. I'm going to straight up just paste it onto the bottom because I know that's what's going to go at the bottom of my next step, right? So if I've got 3 moles of iron or 3 moles of iron at the top, just moles of iron at the top, moles of iron is going to go at the bottom. Now, what is the unit I'm trying to get to in this step? Now, the reason why I've already set this up for you is you should know a mole to mole ratio is just a one-step problem. All I need to do is convert from moles to moles. There's no grams, there's no liters, there's no other unit of measurement. I have to get to mole first so that I can do mole to mole so that I can get out to another unit of measurement. It's straight up just already in mole, so I'm good. So I'm going to say moles of iron is going at the bottom, and the unit that I desire in this question is how many moles of iron oxide, right? So again, I can just copy paste this, just copy and paste. That's exactly what I'm going to need. No, number 2, I don't know why it's doing that. That's exactly what I'm going to need in my problem. So now, how am I going to know what numbers I plug in here? Well, with the mole to mole ratio, you get these numbers from the chemical reaction. So what number goes at the bottom? Well, I'm talking about how many moles of iron per moles of iron oxide. Well, in my equation, I can see that that number is there's 4 moles of iron for every 2 moles of iron oxide, right? So I'm going to put 4 next to moles of iron. And what number is going to go next to iron oxide? Well, again, I'm looking at my chemical equation, and I can see the number 2. So I'm going to say 2. Okay, so to answer the question, I'm going to, of course, multiply the numbers that are across from each other, and I take that top value and I divide by the bottom number. So I could actually do this in my head. You don't have to. You can click on that calculator and type it in, but 3 times 2 is 6 divided by 4. Okay, maybe I can't do it in my head. Is 6 divided by 4 is like 1.5, right? Okay, it's the end of the day. Give me a break. Okay, so I know my answer is going to be 1.5, and then I know that the answer is going to be in the very last unit that I converted to, and that last unit is moles of iron oxide. Okay, so that's your basic mole to mole conversion. Okay, that's the piece that we're going to use in the middle of every single Stoich problem, whether it's volume or whether it's grams. You're going to use that same exact method to go from moles of one substance to moles of another, and then just convert out into the unit that they want you to. Okay, so let's scroll down. Mass to mass. This is the hard one, right? So how many grams of potassium chloride are produced if 25 grams potassium chlorate decompose? Okay, so I know I'm starting off here with 25 grams potassium chloride. So potassium chloride is KCl, right? And ultimately, I'm trying to get to how many grams of Oh, I'm sorry. No. We're starting off with 25 grams of potassium chlorate. Sorry. So we're going to make sure that that says KClO3. Okay. If it bugs you that the little numbers you can't like drop down, first of all, you can use control comma, and that's when it'll make a subscript. Or again, what you can do is you can just be like, oh, that's this substance, highlight it, copy it, paste it. Okay. So if I've got 25 grams of potassium chlorate to start with, and we want to switch to grams of potassium chloride, I know what I'm going to have to do is I'm going to have to convert from grams of potassium chlorate to moles of potassium chlorate, moles of potassium chlorate to moles of potassium chloride, and then moles of potassium chloride to grams of potassium chloride. Okay? So you can do all those things in small steps. We've worked on all the small steps. You just have to put them together. Okay? So we're going to say, again, what goes up must come down. All right? And in the very first step, you're going from grams to moles, KClO3. Okay? When you're doing a mole conversion, just like we did in quarter 3, all you have to do is come up with a formula mass, put that next to grams, and then say that's per 1 mole. Okay? So I am going to have to do a little extra calculating here because I need to figure out what the molar mass of potassium chloride is, or chlorate, I'm sorry. So we're going to take 1 potassium plus 1 chlorine plus 3 oxygens, okay? So we take a look at the periodic table. Potassium is 39.10, chlorine is 35.45, and oxygen is 16. Now don't forget we have to multiply oxygen by 3. Okay, so we're going to say, let's clear this out. We're going to say 39.10 plus 35.45. That's right here, right? Plus, and if you want to do the 3 times oxygen in the same step, we could just do parentheses, 3 times 16. Close your parentheses. It says that's 48. And then it'll add it to your total. Okay, so we've got 122.55. So I know that it's 122.55 grams of potassium chlorate to 1 mole of potassium chlorate. So now we've switched from grams to moles. We're going to convert now from moles of potassium chlorate to moles of potassium chloride. So we're going to take just the unit and we're going to say what goes up must come down. Then we're going to switch to the desired unit, which in this case is going to be moles KCl. Okay, so now in this middle part of the problem, this is where when you're switching from moles to moles, you have to use the mole to mole ratio, and the mole to mole ratio comes from the coefficients in the balanced chemical equation. So how many moles of KCl are there per moles of KClO3? Well, if you look at your chemical reaction here, that's going to be a 2-to-2 ratio. So this one kind of cancels out. So we're going to say 2 moles of KCl for every 2 moles of KClO3. And we got that from our chemical reaction. All right. Now your last step here, as per usual, you're going to say what goes up must come down. You can just copy paste it. And then at the end, your desired unit is what they're asking for in the problem. They say how many grams of potassium chlorate, or chloride, sorry. So we're going to say grams KCl. Okay. Once again, I'm just doing a gram to mole conversion, or mole to gram conversion in this case. So I'm always thinking about the fact that I want the molar mass, which is the mass per 1 mole of KCl. So once again, I'm going to have to do a little bit of calculating here, but it's not much. I'm adding the mass of potassium plus the mass of chlorine. So once again, looking at my periodic table, potassium over here is 39.10. And chlorine over here is 35.45. So together, 74.55. Okay. So I know that there are 74.55 grams of potassium chloride in 1 mole of potassium chloride. Okay, so once again, just a gram to mole conversion, the mole to mole conversion, and then a mole to gram conversion with a new substance. Okay, we're going to multiply everything across, and then we're going to divide by everything at the bottom. So to do this again, I'm going to take my parentheses. I'm going to say parentheses 25 from here times 1 I don't need, times 2 times 74.55. Did I type a 2 in there? 74.55 equals, okay. Now we're going to hit divide parentheses 1, 2, 2.55, that's, I'm down here now, times 2. And again, we don't really need to type times 1. So I'm going to close the parentheses, I'm going to equal, okay? In this case, I get 7.60 grams KCl. Okay, all I did was I multiplied across and then divided everything at the bottom. All right. Last one that I'll do with you guys is liters to liters. Okay, we're going to say what volume of hydrogen is necessary to react with 5 liters of nitrogen to produce ammonia. All right, so I know I'm starting with 5 liters nitrogen, so we're going to go ahead and type that, 5.0 liters N2. And I know that what goes up must come down, so I'm going to immediately take whatever I just typed, and I'm going to copy paste it down on the bottom. All right, my first step always is to get from whatever unit I'm in to moles. So I'm going to say mole N2 at the top. That's my goal. Now I just have to plug in the right numbers to convert from liters to moles. And you guys should remember that that's 22.4 liters per mole. So wherever the liters is, which in this case is on the bottom, we're going to write 22.4. And wherever the moles is, we're going to say 1. Okay, easy peasy. So then we're going to move on to our next unit, or next step. We're always going to say what goes up must come down. So I know moles of nitrogen goes at the bottom. And remember, our second step is to convert to the moles of the next substance that we want. In this case, the question is asking what volume of hydrogen. So I know I'm going to have mole H2 at the top. All right, remember to go from moles of one substance to moles of another substance, we use the mole-to-mole ratio. Mole-to-mole ratio is the coefficients in the balanced chemical equation. So I'm going to start at the bottom because that's where I started this problem. Nitrogen. Now there's nothing in front of nitrogen. Does that mean 0? No, if it was 0, it wouldn't be in the equation. So it's just 1, okay? So we're going to say 1. And then hydrogen, the number next to hydrogen is 3. So I'm going to match that up with a 3. Okay, almost done. These ones go a little bit faster, I think, because we're going to say what goes up must come down. What goes up must come down. And in my last piece of this stoichiometry, I am actually switching from moles to liters because the question does ask for volume. So we're going to say liters H2. Okay, so how many liters per mole? There's 22.4 liters per 1 mole of hydrogen. Okay, that's the same for every substance. It's always going to be 22.4 liters. Okay, so once again, let's just throw it in our calculator and call it a day with this problem. All we have to do is hit parentheses 5 times, I'm not going to say times 1, 3 times 22.4, close your parentheses. Now we're going to hit divide because we want to divide our top number by our bottom number, and we're going to click parentheses again. We're going to take that 22.4, and actually it's times 1 times 1, so we don't really actually need any parentheses. I'm sorry. Equals 15. All right, so we're going to write 15 liters H2. Okay, so that's me walking you through 3 of these problems, each of them a little bit different, mole to mole, gram to gram, liter to liter. There's another one that you need to do in each of those categories, and one more just kind of mixed together so that you're paying attention to the question, because the quiz that you guys are going to take tomorrow, is going to be random. You need to know when you're doing what. So make sure you get a good practice with that. If you have any questions, let me know. Okay, bye.